On to the guided practice. Number 1 is pretty straightforward, right? I do like writing the expression over again. There's nothing to plug into here, so it's just -3. Right? You just plug it in. There's nowhere to plug it into. We're done. For this one, again, same sort of thing, right? We just plug in 5, right? We just get, now note when I plug in 5, I stop writing this. But until I plug it in, I keep writing it, right? And that's just 5/14. Okay. For number 3, well, it looks like we've got a little more work ahead of us, right? Because if we plug it in, we wind up getting 0 over 0. Right? So the limit as x approaches 1 of this lovely expression equals the limit. Again, see, I'm still writing the limit as x approaches 1 because I haven't plugged anything in yet. And then this is going to be, what is this, x plus 2 times x minus 1. Oh, well, that's not so bad. Get rid of that. And now we wind up with 1 over 1 plus 3. See how I got rid of this? Because I plugged in 1? No, sorry, 1 plus 2. I lied. That's 1/3. Okay, so that's an answer. For number 4, well, I think you can see what's happening there. We plug that in, we're getting 16 over 0. No good. So we know that we're dealing with an infinite limit. All right, the only question is, does it exist or does it not exist? I can already tell you this one's not going to exist. Pretty sure anyway. The limit as x approaches 4 from the left. 4x over 2x minus 8. Well, I know the top is approaching 16. That's positive. From the bottom, it looks like 2x is going to be a little less than 8. So it looks like the top is positive, the bottom is negative, and we're getting negative infinity. From the right, well, you can probably guess it's going to be the opposite. Just to be clear, the left-hand limit isn't always negative infinity, and the right-hand limit isn't always positive infinity. That's just how it works out. Okay? Right? But anyway, the end result does not exist. Now, to be clear, even if you know that this limit's going to be infinite, even if you know it's not going to exist, I need to see this. I need to see that. Like if I gave you that on a quiz or an exam, I need to see that. And what is going on here? Well, this is a piecewise function. If you were to graph it, it would look like this, and then like here, and then it would look like, this or something like that, or maybe the parabola would be up here or something like that, and then maybe the dot would be down here or something like that. We have to figure out what's going on with this, right? So what we're doing is we're finding out whether the limits exist, okay? So what that means is we're just going to find the left and right-hand limit, right? Limit as x approaches -1 from the left of g of x. That's a minus sign right there. Well, that's going to equal the limit as x approaches -1 from the left of 2x plus 7, right? Because that's the function for when x is less than 1. So anyway, you just plug it in, right? You get 2 times -1 plus 7 equals 5. It's a semicolon, by the way. Limit as x approaches -1 from the right of g of x. Well, that's the same thing as a limit as x approaches -1 from the right of 3x squared plus 1. Right? And again, how do we get that? Well, again, the plus corresponds to this situation. So that's how you get it. Anyway, you plug it in, and you get 4. So the left-hand limit equals 5, the right-hand limit equals 4, and so the double-sided limit does not exist.